Welcome to our notes for today. We are going to be looking at solving systems of equations. Today we're going to talk about two methods to do that. We're going to talk about how to solve our systems using graphing, and then we're also going to talk about later how to solve systems using substitution. So let's start off with graphing. We have already done graphing linear equations by getting it into the form y equals mx plus b. So that's where we want to start. We need any equation that we're going to graph to be in the form of y equals mx plus b. Remember, where b is your y-intercept that you plot first, and then m is your slope, and it tells you how to get all the other points that fall on that line. Okay, so let's go ahead, and I'm going to use a light blue to graph this first one, and if you'll notice, it's already in the right form, so I can graph the y-intercept of 5. Here's my y-intercept, and I know that it has a slope of down 2 and to the right 1. So from the point 0, 5, I'm going to go down 2 and over 1. I'm going to continue that as far on the graph provided as I can, because right now I don't know what the other graph is going to look like. We do want to connect these dots with a line and put some arrows on the end, so you'll want to connect these, putting an arrow on the end showing that it's a line and going to go on forever. Okay. Now what we want to do is we want to graph the other equation. So I'm going to do this one in gray. Now, oh no, something's not okay with this equation. The y is not by itself. It's not in the form y equals mx plus b. So the first thing we need to do is subtract the x from both sides. So we have 3y equals negative x. I don't need to put plus 0 because adding nothing is not going to change it. And then I need to get rid of the 3, so to undo that we use division. So we have the equation y equals, and I'm going to separate this. That way the coefficient is separate from the variable. So the coefficient is negative 1/3 and the variable is x. Okay, I'm going to go ahead and write the plus 0 just so you guys can see the importance. This is the y-intercept. So that means my y-intercept needs to be here at 0, 0. Then we're going to do our slope, which is down 1 to the right 3. So from 0, 0, we're going to go down 1 to the right 3. Down 1 to the right 3. Now I'm going to do that in the other direction. So up 1, left 3. Up 1, left 3. So I did it as far as I could from left and right. I'm going to connect these dots and arrow on the end. Now, when we're solving by graphing, we're going to graph both lines like we did and determine the point of intersection. Okay? The reason we want the point of intersection is because that's the solution. So this point of intersection, this is the solution to the problem. Okay? Well, here it is, and now we need to know what's that ordered pair. So the x value here is 3, the y value is negative 1. So the solution is 3, negative 1. Okay, let's go ahead and let's go and look at the next example. Okay, we've got graph both lines, determine the point of intersection. So we're finding the solution to these two equations, a system of equations. That just means we have more than one equation. So if you look, the first one is already in slope-intercept form. So we're going to take our y-intercept and graph it on the y-axis at negative 1. And our slope here is rise 3, run 1. So we're going to go up 3 lines and over 1. Up 3 lines and over 1. I want to continue it in the other direction as well. So down 3 lines and to the left 1. So let's go ahead and connect these dots. Arrows on the end. So we got the first one done. Now let's do the second one. Okay. If you'll notice, the second equation is not in slope-intercept form, so that means we need to get the y alone. Always the first thing you need to look to move is the x piece if it's on the same side as the y. So you always move that with addition or subtraction. So here it's subtraction because 6x is positive to begin with. So we get 2y equals negative 6x plus 10. Yes, please put the x piece first. That way you have it in the right slope-intercept form so you can identify the slope and the y-intercept. Then we need to get rid of this 2, so we're dividing every single piece by 2. So we have y equals, well, negative 6 divided by 2 is negative 3. There's my x. And then 10 divided by 2, that's positive 5. So we've got a y-intercept of 5. That's up here. And then we have a slope of down 3 to the right 1. So from this y-intercept of 5, we're going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. Okay, and we're going to connect these dots with a straight line. Hopefully we see a point of intersection. It's right here, so we just have to identify what that ordered pair is. This ordered pair has an x of 1 and a y of 2. So the solution is 1, 2. Okay. Now, before we move on, when we had this first equation right here, we saw that the slope was positive. So that means my light blue line should be increasing. So as I look at it from left to right, it should be going upwards. If we notice, the dark blue equation had a negative slope, so that means that line should be going in a negative direction. It should be going downward as we read it from left to right. That's always a good little check so you can make sure, did I even graph these correctly? Okay. If your two are not intersecting, okay, that's okay. We'll see what that looks like. But you do want to make sure that yours are graphed correctly, because if not, you're going to get the wrong solution. Okay? I'm going to help you on this one make sure that our equations are in the right form, and then I'm going to have you guys graph it on your own. So on this first one, I'm going to do, again, light blue. The first piece that we want to move is the 5x. So to do that, we subtract 5x on both sides. So negative 2y equals negative 5x plus 10. To get the y completely alone, we're going to divide, that's undoing the multiplication, each piece by that negative 2. So we have y equals, okay, negative 5 divided by negative 2, so negative divided by negative becomes a positive. 5 over 2 does not reduce, so just leave it the fraction 5 over 2. Please don't change it to a decimal. We don't want to change these fractions to decimals because it's going to tell us how much we rise over how much we run. Okay, so we've got our x next to the 5/2, and then 10 divided by negative 2 is a negative 5. All right, I'm going to go down and let's get the second equation into the right form. So we need to move the 2x with subtraction. So we get y equals negative 2x plus 4. What's nice is we don't have to do anything else. That's already done. Okay? So I want you to go ahead, pause the video on your own, on your paper, graph both of these equations, find where they intersect, and label the point. So go ahead, pause it now. Okay, welcome back. This is what your two graphs should look like. Your light blue, my light blue graph has a positive slope. Okay. My dark blue graph has a negative slope, and they intersect at the ordered pair 2, 0. Please make sure your ordered pair is written in the right order, the x first, then the y. If not, you're telling me a different point. If you put 0, 2, then you're actually saying on the y-intercept that that's where they intersect. So please be careful with that. All right, so that right there is solving by graphing. So what I'm going to do is we'll stop this video here, and then the next video will have solving by substitution.